Assalamualaikum. Hi guys. This is new chapter periodic table where we have two subtopics here. We are going to focus with 3.1 classification of elements where you have these all are our learning outcomes. Let's go with the first part of this video. I'm going to explain to you how to describe period, group and block in periodic table. This is periodic table of the elements where we know all of those elements are arranged in order of increasing proton number. In other words, increasing atomic mass. For the horizontal row, we call it as period. So we have period 1 until period 7. The next one, we have vertical column of the elements which known as group. So we have group 1 until group 18. In this part, there are three terms that you have to know: period, group, and block. I'm going to explain one by one. Let's focus with period. Period is the horizontal rows of elements in periodic table where we know we have period 1 until period 7. So how to determine period? Period depends on the highest principal quantum number n. I hope you still remember about this. For example, I have sodium and chlorine. So this is electronic configuration for sodium and chlorine. We can know that sodium and chlorine are in period 3 because the highest n value for them is n equals to 3. So I hope you can still remember how to write the electronic configuration and how to determine the highest n value. Hence, we can conclude that period number equals to the principal quantum number. Let's go to group. Group is vertical column of elements in periodic table. We know there are 18 groups of elements numbered from group 1 until group 18. So in order for us to determine the group of specific element, we have to know how to determine the number of valence electrons. So if you take a look here, I got magnesium and boron, where you can determine the number of valence electron for them based on electronic configuration. For example, magnesium, we have 2 valence electrons because we got highest n value, which will be n equals to 3. That's why you have 2 valence electrons for magnesium. And then for boron, you can see that the highest n value is n equals to 2. So in n equals to 2, you have 2 subshells, subshell 2s and 2p, where the total number of electrons in them will be 3 because you have 2 here and 1. So the valence electron for boron is 3. Next, in order for us to determine the group number, there are 2 rules that you have to understand. For element in block S and block D, for example, group 1 until group 12, you have to know that the group number will be the same with the number of valence electron. However, for element in block P, for example, elements in group 13 until group 18, their group number will be the same with number of valence electron plus 10. So, in this case, I can know that magnesium has 2 valence electrons, so that's why it is in group 2. Next one, you have boron with 3 valence electrons, but you can see that boron is in P block. In this case, you have the last field subshell 2p1. So that's why we have to add 3 plus 13. So boron is in group 13. Please make sure you use the number to indicate the group. Please don't use like this. For example, you write group 2 for magnesium. This is wrong. You have to write down group and then 2, number 2. This is the correct one. Same goes for the period. Next, you have to know that there are several different names to indicate specific group. For example, group 1 can also be called as alkali metals, group 2 alkaline earth metals, Group 3 until 12, this is what we know as transition metals, or another name for that is D block elements. Group 16 is chalcogens. Group 17 is halogens. And group 18, inert gases, or we call it as noble gases because they are all stable. So that's it for group. Let's go for block. In periodic table, we have to know that elements are classified into 4 main blocks, as you see from this picture, according to their valence electronic configuration. The short form that I can use for this part is VEC. So, awak akan selalu dengar saya sebut this term, valence electronic configuration, as VEC. So, there are 4 main blocks, as you know, S, P, D and F block. Sama macam kita bagi name for orbital. So how to determine the block? Block depends on the last fill subshell. So maknanya you have to understand how to fill in electron based on Aufbau principle for their electronic configuration. Let's go with the first block, S block. S block only for group 1 and group 2 elements, where the filling of the valence electrons involves only s orbital. And for S block, we have a specific VEC, which will be NS1 until NS2. So ini untuk group 1, ini untuk group 2. For example, saya ada sodium, which the last fill subshell will be 3s1, so I can conclude that sodium is in S block because the last electron, the 11th electron, will be in subshell 3s, so S block. Next, I have calcium. Calcium we have here is the last fill subshell is 4s. We got 2 electrons in it, so you can determine calcium is in S block as well. Next, we go for P block. P block only for elements in group 13 until 18. The VEC for P block is NS2 and P1 until NS2 and P6. You can see this is for group 13 until group 18. 2 tambah 1, 3. 2 tambah 6, 8. For example, I have aluminium. This is electronic configuration. For aluminium, you can see that the last fill subshell is in 3p. So, I can conclude that aluminium is in P block. Next, I have tellurium. So, this is the atomic symbol for tellurium. You can see that the last fill electron is in subshell 5p. So, we can conclude that tellurium is in P block as well. Next, we go for D block. D block is for element that we know as transition elements or D block elements. This is for elements in group 3 until 12. So, these elements biasanya berada di tengah-tengah periodic table. VEC for this D block will be N-1 D1 NS2 until N-1 D10 NS2. You can understand more by using this example. For example, I have vanadium. Vanadium, we got 23 proton number, so electrons should be the same. So the last fill subshell will be in 3D3. Please remember, kita follow Aufbau, di mana for Aufbau, we fill in electron dalam 4s dahulu, barulah the rest of them 3D. Will be in 3D. So dalam kes ini, the last fill subshell will be, hence, we can conclude that vanadium is in D block. Sama juga kalau saya ada nickel. Nickel, we fill in 1s2, 2s2, 2p6, 3s2, 3p6, 4s2 dahulu, barulah selebihnya 3d8. So, the last fill subshell adalah subshell 3d. Hence, we can conclude that nickel is in D block as well. The last one, we go for F block. So, F block is for the elements in the series of lanthanides and actinides. So macam mana kita nak tahu for this part? Biasanya valence electrons for this element in F block will be filled in the subshell of 4F and 5F. For example, you have in the periodic table the additional 2 rows there. We have the lanthanide series, the top one, and actinide series, the bottom one. So this one will be lanthanide and this one will be actinide. So as a conclusion, you can know that it is very important for you to know how to determine the valence electronic configuration for your atom or your element. So kalau kita nak tentukan VEC, benda yang paling penting, you have to know and memorize very fast how to do the electronic configuration. Kalau tak boleh write the electronic configuration, you cannot classify the elements in the periodic table. So that's it for this video. I will continue in the next one. Bye!